Hi guys, so let's get started on going over this homework. So there are 6 substances listed: calcium, magnesium, sodium, potassium, chlorine, and sulfate. And the level that's listed in the cell is what the cell wants to be at. Okay, meaning, well, it's really what the cell needs to be, because if it's not at those levels, then the cell could die. So these are the levels that the cell needs to remain at. Now, a cell put in any kind of water, if it has dissolved substances, that means that things are going to pass back and forth across the membrane. Now, with these substances in particular, they're really small, which means they're going to be able to go through the membrane either through the phospholipid bilayer or through those ion channels or transport proteins. Okay, so the first one is magnesium. Now we're going to determine if the cell needs to do diffusion, osmosis, active transport into the cell, or active transport out of the cell in order to remain at those cellular levels. Okay, so with magnesium, the cell needs a very, 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 very small amount of magnesium, 0.005. Okay, now right off the bat, the 6 substances we have, none of them are water, which means for numbers 1 through 6, osmosis will not be an answer, because osmosis is only water down the concentration gradient through a membrane. So we've already cut one out, narrowed it down. So magnesium. So all of this, we're looking at the cells if they were in seawater. So magnesium has a level in the cell of 0.005, and that's where the cell wants to stay. You put that cell in seawater, and the levels of magnesium in seawater is about 57. Much, much higher than inside the cell. So what is naturally going to happen is that magnesium is going to diffuse into the cell. And as magnesium diffuses into the cell, what happens to those magnesium levels? They go up. Okay? Now, you don't want the levels to go up. The cell doesn't want the levels to go up, which means in order to stay at 0.005, the cell is going to have to pump magnesium out of the cell on a regular basis, kind of like how you have, like if you have a leaky boat, the boat's filling up with water, you have to bail out the water, right? Well, in this case, the cell is taking on magnesium, and it needs to bail out the magnesium. And it's moving from low concentration to high concentration, which would mean the cell has to, with magnesium, actively transport magnesium out of the cell in order to stay at the 0.005 level. Sodium. Now, we've already talked about sodium when we talked about the sodium-potassium pump. So you should know this without even looking at the levels. Okay, you should know that because when we talked about the sodium-potassium pump, you know that sodium gets pumped out and potassium gets pumped in. But let's say you didn't know that already. Your sodium level in the cell is 90. That's where it wants to stay. In the seawater, it's 500, much, much higher, which means the cell is going to be constantly taking on sodium, and the cell needs to actively pump it out, just like with magnesium. Potassium. Sodium, potassium pump. Sodium gets pumped out, potassium gets pumped in. And how do you know that? Well, you need to have very high levels of potassium in the cell, 480 to 500. In seawater, the potassium levels are very low, okay? Which means that potassium is going to be constantly going out of the cell. You don't want that. You want the levels to remain at the same. You want the levels to remain the same in the cell, which means it's going to have to constantly pump potassium back into the cell. So that would be active transport into the cell. So active, all of this stuff, active, remember, pumping, active transport requires energy. Okay, it's moving against the concentration gradient. It's moving from areas of low concentration to areas of high concentration. Let's take a look at calcium. Let's get rid of these. Calcium, 1.7 in the cell. It's much higher in seawater, which means cells is going to be constantly taking on calcium. The calcium is diffusing in. The cell doesn't want all that calcium, which means it has to pump the excess calcium out. Chlorine is one that's a little bit different because cells can have a range of chlorine anywhere from 500 to 600, okay? Now, seawater is typically about 520. That's right in the middle of this acceptable range for the cell, right? So if seawater is about 520, the levels in the cell, they can go down to 500, they can go up to 600, which means the cell really doesn't need to do anything in order to balance those levels. They're going to be balanced in the cell by simple diffusion. And last, for sulfate, if you have 0.01 in the cell, seawater is 36. Again, the levels are much higher outside of the cell, which means sulfate is going to be diffusing in. Cell doesn't want all of that sulfate, so it has to actively pump it out. And for the last three questions, we're looking at the cell not in seawater, but in brackish water, which is kind of a tidal zone. It's like kind of a combination of like seawater and freshwater together. So, which substance enters and leaves the cell by osmosis in both seawater and brackish water? You should be able to answer this question without even looking at the table, because the substance enters and leaves by osmosis is always, say it with me, water. That's the definition of osmosis. It's the movement of water down the concentration gradient through a membrane. So you don't even need to look at the table in order to do that. If it enters and leaves by osmosis, it has to be water. Now, which substance is actively transported out of the cell into both seawater and brackish water? So when we're looking at these levels here, we're looking at the substance. Remember, if we're looking for the substance that has levels that are higher outside the cell than inside the cell, because if the levels are higher outside, then that means that the stuff is going to be diffusing into the cell, and the cell will have to actively pump it out. So which substance has a lower level in the cell than both seawater and brackish water? Calcium. We'll start with calcium. Well, the cell is 1.7. Brackish water is also 1.7. So if they're already balanced out, that doesn't need to be actively transported out of the cell. So it's not calcium. Chlorine. Well, we've already talked about chlorine. 500, 600 in seawater, it goes in and out by simple diffusion. So it's not chlorine. Magnesium, 0.005. 57 in seawater and 6.5 in brackish water. Both types of water are higher than the level inside the cell. And just for kicks, let's take a look at potassium. When we look at potassium, the levels are much higher inside than outside, which means that potassium is going to be actively transported into the cell when it's in seawater. So the only one that has to actively transport, the only substance that needs to be actively transported out of the cell in both types of water is magnesium. And then which substance enters by active transport in brackish water and leaves by diffusion in seawater? Well, you should already we already figured out which substance moves by diffusion in seawater. Chlorine. Between 500 and 600. 520 in seawater, that's going to be diffusion. Now let's double check and make sure that it will enter the cell by active transport. The level in brackish water is lower than the cell needs to be. Therefore, the cell will start losing chlorine. Doesn't want to. It will actively pump it back in. And therefore, our answer for 9 is chlorine. I will be posting the answer key to this homework on Schoology, and the gizmo that you're going to be working on for the remainder of class, I will have, and that is all about cells living in water, paramecium living in water, and how they need to actively transport water out of the cell in order to remain balanced. So I'm going to have the key to that posted on Schoology as well. Please feel free to email me with specific questions, and make sure you use your study guide and all of the homeworks and labs and everything that we've done leading up to this, because your test is next class. So make sure to email me any specific questions, but your homework is to study. Finish that gizmo, check the answers on Schoology, get this homework, check the answers on Schoology, and I will see you guys hopefully next class. Everyone have a good one.